Welcome everyone. Thanks for watching. In this video, we're going to integrate this integral. So it's not so easy to integrate this because you see these angles are different. So when that happens, U substitution doesn't seem to help much. You could try integration by parts, but it will be quite some time to finish. So we have to come up with better technique. So one way you're going to approach this is to apply some trigonometric formulas. Here are the formulas we're going to use. Recall sum and difference of two angles. For instance, if you have, let's say, sine of A plus B, we know from pre-calculus that this is equal to sine A cosine B plus cosine A sine B. And we also know that sine of A minus B, difference of two angles, is equal to. So it's almost the same formula, except you put a minus sign in between the terms. So I'm just going to copy the formula and put a subtraction right here. So this is going to be useful. There are two more formulas that we should also write down. We know that cosine of A plus B can be expressed as cosine of A cosine of B minus sine A and sine B. And we also know cosine of A minus B is also a similar formula as cosine of A plus B, except you put a plus sign in between the terms. So I'm going to go ahead and rewrite that and modify it. So these are the tools that are going to be helpful for this integral. So I need cosine times sine. So if you look at these formulas, that appears to be right here, cosine and sine with different inputs. So what we can do is we can either add or subtract these two formulas. Now you want to add them, not subtract them, because if you subtract the two formulas, then these guys will cancel. You don't want that. You want them to survive and then modify the formula. So let's call this one formula 1. Call this one formula 2. This is 3. This is 4. So if you simply take formula 1 and formula 2, you add them up, you're going to get something that will help us to integrate. So let's go ahead and do that. Take these two and add them up. So if I take formula 1 and formula 2 and I add them, I will get the following formula. So on the left side, you add these up. So you'll have sine A plus B plus sine A minus B. Now on the right-hand side, if you add these, you'll see the cosine A sine B, cosine A sine B, the negative, they'll cancel out. So these two cancels out. So you're left with two of these. So you're going to get equal to 2 sine A cosine B. So now, if you look at our integral, we're solving for sine A, let's call it that, and cosine B. So I want to solve for that formula. I simply divide both sides by 2. So that gives me sine A cosine B is equal to 1/2 sine of A plus B plus cosine of A minus B. And that is the formula we want to replace in our integrand to be able to integrate this function. So hopefully this is making sense. So let's use this. This is a new formula, and this is what we're going to use in our integrand. So let's copy this and pull it downstairs. So you see how we have exact same thing. So you can think of it as this is sort of your A value. So you can ignore the X if you want. Think of it as this is your A, this is your B. Let's substitute them into that formula. So we will have the integral of 1/2. So this is 1/2 the integral of sine of A plus B. So that's 3 plus 2x plus sine of A minus B. That's 3 minus 2x dx. So that's what we're integrating. And then if you rewrite the inside of each of these functions, so you have the integral times 1/2 of sine of 5x plus sine of x, 3 minus 2 dx. And we know how to integrate each of these. They're pretty straightforward. We know them from our previous knowledge. So this is 1/2 times the integral of sine is negative cosine of 5x divided by 5. And then again, integral of sine, that's negative cosine of x plus c. So that is our final answer. And you can clear out the negative and distribute the 1/2. So this is negative 1/10 cosine of 5x minus 1/2 cosine of x plus c. So that is our final answer for this problem. Here is another similar problem. We have sine of 3x and sine of 5x. So we're going to be using the formula we wrote down earlier. So these are the formulas, sum and difference of two angles. Now you want to look for where you have sine A and sine B. So sine A, sine B appears right here. So that's what I want. So that means we need to either add or subtract formula 3 and 4. So it looks like if you add them, it's not going to work because these are going to cancel out. So we don't want to add them. Instead, we're going to subtract them. So I can do the following. I can take formula 4 and then I can subtract formula 3. Then that would help us to find what we want. So if I do that, so I'm subtracting these two formulas in this order, 4 minus 3. So on the left side, we'll have this minus that. So we're going to have cosine of A minus B minus cosine of A plus B. And on the right-hand side, these are going to cancel out. So they disappear, and then we have sine of A sine B minus minus. So the two negative makes a plus. We will have positive 2 sine A and sine B. And now we want to solve for sine A and sine B because that's what we have in our integrand. So we have sine A and sine B is equal to divide by 2. So 1/2 times cosine A minus B minus cosine A plus B. So we can rewrite our integral using this formula. So your best tools are these 4 formulas because you can manipulate them and get what you want. So let's take a look at our integral. So we're integrating sine 3x times sine 5x. So using this formula, we're going to rewrite this. So you can think of as this is your A and this is your B. So this integral is equivalent to 1/2 the integral of cosine of A minus B. So that's 3 minus 5x minus cosine of A plus B. So that's 3 plus 5x dx. So this is what we're integrating. I'm losing a little space here. So let's just push that right there, integrating respect to x. Now let's simplify the inside of these functions. So we have 1/2 the integral of cosine of 3 minus 5, that's negative 2x, minus cosine of 3 plus 5, that's 7x dx. All right, so now here you can proceed to integration, but I'm going to go ahead and simplify that. Since cosine is an even function, instead of looking at negative 2x, you can just simply write that as positive 2x. So here I'm going to rewrite this 1/2 the integral of cosine of 2x, and cosine 7x stays as it is. So here I use the even function property. Now I'm going to go ahead and integrate these. So this is equal to 1/2 times cosine of 2x. The integral of that is sine 2x over 2 minus, now distribute the 1/2 to cosine 7x. The integral is going to be sine of 7x over 7 plus c. And now we can simplify our answer. So this is equal to 1/4 sine of 2x minus 1 over 14 sine of 7x and plus c. So that is our final answer for this problem. So the key to this problem is to really being able to manipulate these four formulas and see what do you have in your integrand and then work with that. All right, so I hope this makes sense. See you next time.